Hey guys, welcome to another episode of HashWise Convo. Joining us today is Matthew from Spire Labs, a key player in developing Base Rollups and their innovative based stack. Good to have you here, sir. Thank you for your time.
Thank you. Let's get started.
Yeah, before we dive in, could you briefly introduce yourself, maybe to our listeners who don't know about you much?
Sure. So my background is in MEV. I did MEV searching for about 5 years after getting into crypto. Pivoted focuses a couple years ago into Ethereum research. Did a lot of stuff on inclusion lists, censorship resistance, and sequencing. Then spent a lot more of my time around Base Rollups. I got really pilled by Justin Drake, and then met my co-founder Kaito, and we started Spire Labs together. So yeah, I'm really bullish on what we're building. I think it'll be this big Ethereum narrative. There's a very solid chance of that. So I want to, give you guys some alpha, and hopefully we can dig through some of the interesting bits.
Yeah, sure. You touched it a bit already, but can you introduce maybe the core concept of Base Rollups for listeners unfamiliar with the term itself?
Sure. So there's like a technical definition that we could get into. I think it's pretty easy to instead approach this from like the fragmentation versus composability lens, where existing rollups today are isolated because they have centralized sequencers, and this means that it's hard to coordinate interoperability between them because you essentially need two sequencers to agree instead of one, and that is a very difficult thing to do trustlessly, right? And so if you don't have this coordination, you have a massive reduction in the effective usability of your network. Everything is less capital efficient, and yeah, it's just a poor user experience. With something like shared sequencing, then you have sequencing that can be coordinated across multiple domains, like multiple layer twos, which is really nice for those layer twos. But unfortunately, shared sequencers have a pretty bad cold start problem, and also have some other technical issues that I won't get into now. But essentially, there's some recent research that's been published that we kind of learn that shared sequencing by itself is not enough for atomic arbitrage and some forms of MEV that are required for capital efficiency, because they can't like trustlessly move around assets. You can execute two transactions on different domains, but unless you can like bridge instantly as well, then the actual arbitrage capture ability that's generated by the existence of a shared sequencer is quite low. And then the third stage here is base sequencing, which is just like shared sequencing. It's very similar, except that the Ethereum layer 1 is also a participant in the shared sequencer system. It's a subset of shared sequencing that includes the layer 1. And this is helpful as a foundation because this allows you to do some interoperability with Ethereum layer 1, but not as much as you might think, right? So if you want to do a cross-chain contract call from layer 1 to layer 2, you also need some other pieces that I'm sure we'll get into later, but there's a bunch of teams working on taking base rollups from like level 1 to what I call the next generation base rollup. And just to throw out a few teams, there's Spire working on that. There's Gwyneth from TechCo and HashWise Labs for building Rise Chain. So I think there's a whole bunch of interest and innovation going on in this field, but the fundamental problem that we're trying to address is fragmentation. And the way that we do that is through a special twist on base sequencing, base rollups.
Yeah. From that standpoint of view, it sounds like base rollups are a kind of superior tech. Do you envision future where like L2s that are being produced in these days becoming like base rollup?
Yeah, good question. So yeah, I mean, I agree. Base rollups are usually superior for many use cases, for many circumstances. Now, the clearest answer I can give you is that just because a product is technically superior doesn't mean it will gain adoption, right? In fact, in crypto, we've seen that like a technically worse solution can gain market share rapidly, right? All you need is to launch a token. I think we're at a bit of a crossroads right now where we're trying to build a technically better product, but we also need to understand that a technically better product is in many cases not what actually matters for adoption. And so one of our other kind of pushes here is understanding incentives at a more granular level. So we can offer a technically better product that's faster and cheaper, but if it doesn't return like strictly more revenue to applications, we think we'll have a hard time getting adoption. So that's another one of our big features here, is allowing apps to capture the sequence of revenue that they would be leaking to a layer 2 or to the layer 1. And so because of that, I do think many apps on layer 2s will choose to move to their own Base Rollups, to a based app chain. But I don't know about the big layer 2s themselves. I mean, I really hope that they become based eventually, but I think that's only going to happen if the incentives exist such that, you know, all of their apps are leaving, right? And they're put in a situation where the kind of incentive alignment for the layer 2 and the app is different, right? The app has some amount of sovereignty. And so I think maybe one way to describe this is like Base Rollups are kind of a social pressure to avoid a large layer 2 staying with a centralized signature, because a Base Rollup is a really good technical solution. And once apps start adopting it, I think we'll see a lot more pressure on the big layer 2s to switch over to decentralized sequencing, first of all, but also join the larger Base Rollup ecosystem.
All right.
Would you?
Yeah, you
Go
said
on.
that maybe the most technical, the best tech doesn't win always, and I agree with that. But I think that the thing that matters the most is the user experience. Maybe people are leaving Ethereum ecosystem because in Solana you have just one chain and it's plain, simple, easy. So how does it look on the Base Rollup for users? Let's say I just want to use some apps. I just want to swap some tokens, put it onto the lending protocol. How does it look like from my experience as a user to use such a Base Rollup?
Hey, great question. So I think the clearest unlock is actually for developers and for arbitrageurs who kind of form the infra backbone of a rollup. But that doesn't mean that there's not some really clear benefits for users as well. So one example I like to give is like the onboarding process to a Base rollup, because there's like atomicity and shared sequencing between the Base rollup and Ethereum layer 1. If you have ETH on layer 1 and you like to use an app on your base layer 2, then that's really easy. It's just one transaction that you send on layer 1 and can be interpreted and executed on layer 2 instantly, right, in one Ethereum block. Now, for today, right, you can imagine that user experience is a little bit more painful. Like if I want to use GMX on Arbitrum, but I only have ETH on Ethereum, I need to go to GMX, figure out that it's on Arbitrum, and I need to open up a bridge, be able to use a cross, transfer my ETH or bridge my ETH to Arbitrum, wait for some delay, and then go back to my app and actually start using it. And so we think this kind of hiccup in the onboarding process is one that can be really addressed here. And then other than that, like the user experience of a Spire app chain will be like technically superior on many metrics. For example, like instant pre-confirmations. So you can see faster soft finality than Solana, which I think will be super cool. And then additionally, like as chain abstraction starts to grow in mindshare and adoption, we believe that the user experience for all of these chains will end up looking like there is no chain at all, right? Or there is just one chain. So I think for now, it's fair to say that Solana has a strictly better user experience when it comes to like the complexity of looking at a whole bunch of chains. But in the future, I definitely don't expect that to be true.
Yeah, could you maybe be more specific here? Like, let's say I have some ETH or USDC or whatever, and I have it on whatever chain, Ethereum, Arbitrum, Optimism, Base, whatever. Do I interact with the application on the Base rollup the same if I have it on Ethereum L1 or any arbitrary L2, or are there differences?
Great question. Yeah. So if you have your funds on a layer 2, you need to get these back to Ethereum before you can start using or like onboarding to the Base app chain. Now it's certainly possible to have bridges between layer 2s that are like intent based, something like a cross. But At the current time, no, because the canonical bridge of the base rollup is to Ethereum, and so anytime that you're making this interaction, and you need to go directly to the layer one through the layer one at some point.
Okay,
That's
so yeah. Sorry.
I think it's a short term truth. Like in the mid game, I would expect to see a large rise in like content based applications that can fill bridging across any chains. But there's like a fundamental requirement that to bridge to a layer 2, you need funds on layer 1 to enter the bridge contract.
Cool. So you're envisioning L1 as the liquidity layer and just apps as base rollups on that layer.
Yeah, that's a great question. So the layer 1 in my kind of mental model is a host for a bunch of services for applications. I think the easiest way to describe this would be oracles. So oracles are like a service that's required for many, many applications. And one of the difficulties with layer 2s today is that you need to get an oracle deployment on your layer 2. Whereas with a base rollup, you can just use an oracle deployment that already exists on layer 1. And we think that as the way I think of it is like the layer 1 can host a subset of its own state that is like really accessible for base rollups, which enables some really strong guarantees for base rollups. Now, when it comes to liquidity, I'm not sure where liquidity will live. I think it depends quite a bit on the gas costs of the contract interacting with that liquidity. And I think Ethereum, it's very possible that Ethereum has too high gas costs for some situations. Like you'd like to do more computation, you'd like to have your kind of arbitrage threshold lower. And so I think it makes sense for quite a bit of liquidity to exist on layer 2. But that's obviously more of a long-term thing. And it really just depends on where the liquidity incentives are actually directing that liquidity, because as we've seen, liquidity is pretty sticky today. The other thing I'll mention is that, like, I mentioned oracles before, but we can also think about asset issuance as taking place on layer 1. So there's a canonical version of an asset that can be used across every layer 2. So here's another user experience one. There will be no USDC.E on a base rollup. You just use native USDC from Ethereum. You have the native access there. So I think that's another cool one. One other thing that I also like to think about is like the guarantees that Ethereum itself as a sequencer offers, like liveness and censorship resistance, that themselves will just be inherited into every base rollup. So we can focus on making the Ethereum layer 1 better. And this has like excellent positive impacts on every existing base rollup.
Yeah, I have to ask here, is the time now to build like base rollups? Because when I'm like, how I'm seeing the space right now, right? So we have a couple of projects that are rollup as a service, and it's like basically provider, hey, 3 clicks and your rollup is done. Basically DA, whatever, everything on the back end is just quick. In these days, we have institutions coming and becoming L2s on Ethereum. Like, we don't see yet a much traction in or around like base rollups. And that's what I want to ask you, like, about your base stack. Like, is the time now to build a base rollup?
Yes. I mean, we're not limited anymore by Ethereum layer 1. The protocol is upgraded enough that there's capabilities for like DA within Ethereum layer 1 through EIP 4844 blobs. But there's also like just technological improvements that I think are either now or coming very soon. One of those is like real-time proving, which is required for cross-chain contract calls from layer 2 to layer 1 and from layer 1 to layer 2. And so I think that will be something that we'll see, as fast as we need it in like 6 to 12 months. In some cases, some kind of like specialized cases, and then a more general solution in maybe 18 months. And I think that's about the point where we start to base rollups are like so clearly technically better than other rollups because of they can interact with Ethereum's network effect and form a network effect of their own. Now, I mean, the other answer to that question that some people would claim is that there are alternatives to launching an app chain. So we've seen application-specific sequencing or ASS. We've seen like layer 2s that promise to give sequencer revenue back to applications. These are all solutions that are alternatives to launching an app chain. But the downside of these solutions is that they don't scale, right? Like application-specific sequencing, for example, actually scales negatively, right? It negatively impacts the gas costs that your users are paying. And so I think it's a very different kind of trade-off space. Like what we're selling is like the full package, customize everything about your app chain. That's the original app chain vision, but also give you really solid sequencing and guarantees on that, so you can capture MEV. Whereas if your only goal is to capture MEV and you don't care about scaling, then something like application-specific sequencing might work for you. But yeah, so far we've seen, talking to applications, that's like definitely not where the preferences are.
And are we talking about applications already deployed on Ethereum Mainnet or the new ones coming into the space?
A mix of both, for sure. Yeah, so we're talking to some layer 1 applications that have interest in launching app chains, but we're also talking to applications that exist on layer 2 that are already deployed, and then of course new developers as well, as they try to determine what the best kind of infrastructure option for their specific use cases.
What's kind of a complexity for applications to become Base Rollups? Like if you're talking to them, is it for them like, I don't know, also 3 clicks of a button, or is it like months of work?
Yeah, good question. I think the dream for us is that Base Rollups are just as easy to launch as traditional centralized sequencer rollups, on a very special condition, which is that the customizability that Base Rollups offer is actually being used by applications. So it's like the user experience or developer experience can be 3 clicks, right? That's possible. But I think it's even more powerful to actually extend that process a couple days, maybe, to actually customize an app chain to what is best for your users. And so like I think leaving yourself with like a cookie cutter rollup is not going to actually be very useful for your users or for your application. But if you can use features that Spire offers, like customizable composability, interacting with oracles on layer 1, then I think that's something that can be potentially super valuable. So it's like, yes, user experience can be really simple, but no, I don't think many applications will choose to just get like a cookie cutter feature.
And you touched on one quite important thing a few minutes back, and you said that with application-specific sequencing, the fees grow as the demand grows. And I heard one other podcast that you made, and you said there that if you have more based app chains, the cost actually decreases, if I remember correctly. Is it so?
Yeah, this is where we get into the incentives a little bit. It's a favorite part of my conversation for me, and I want to highlight, like, base sequencing is more expensive than centralized sequencers sequencing if there's no like network effect here. It's like strictly more expensive because you're doing many of the same things, except your sequence is also ending up on Ethereum layer 1, which means you have to pay layer 1 gas. So you're paying for blobs and also for a little bit of sequencing. Now, the nice thing here is that the commitment to a sequence that Spire posts to the layer 1 can be kind of recursively wrapped up or rolled up into just one commitment for every app chain. And so, if you have 5 app chains, you don't need 5 commitments. You just need 1 commitment, and then that can be interpreted by each of the app chains on their own. And so the more app chains that are on board, the costs stay roughly the same, perhaps even go up a tiny bit. But because there's so many that are each kind of sharing the cost, we call this amortization, then the cost per app chain goes down substantially, right? So you have like an interesting scenario where the network effect of based app chains actually contributes directly to the network effect of other app chains. So it's a flywheel, it's a positive incentives. And I think that once we reach some critical point where the cost of running a based app chain is like barely more than a centralized sequencer, will actually be just such a clearly better option on every metric, including cost.
Yeah, I think I have just a dumb question here. Could you maybe go a little bit under the hood of how those base rollups actually work? Like, why is it that cheaper if you have more these rollups? Like how does it actually work? What's happening there?
Excellent question. Yeah, so let's get into the way people have thought about Base Rollups for a while, which is very simply that you have a sequencer that is rotated every 12 seconds, and then you try to make that sequencer also the Ethereum Layer 1 proposer. And so you're in a bit of a nice circumstance, I guess, which is that the proposer for the Layer 2 and the proposer for the Layer 1 are the same, and that allows for shared sequencing, which is nice. It's helpful, but it's not actually that valuable. Kind of the next generation of Base Rollups, and by the way, this is what Techo does in the last example. The next generation of Base Rollups, many of them add a additional kind of step here, which is that the blocks that are sequenced by the proposer are committed to on Layer 1. And importantly, this means that they reorg with Layer 1. So if the Ethereum Layer 1 has a reorg and blocks that are not finalized are removed from the chain essentially, then the Base Rollups would also reorg. Now, the reason this is important, because this is like an absolute requirement for composability with Ethereum's liquidity and protocols. You just need to reorg with Layer 1 if you want to compose with Layer 1. And the other upside of this is that this like middle step where you're committing to a sequence on Layer 1 is actually a great opportunity to add additional features that are dedicated to composability and other like nice features for the app chain. So, one example is like censorship resistance, where we have kind of zero block forced inclusion delay, so we inherit the censorship resistance of the Layer 1. I think that's a super valuable kind of construct on its own, but we can get into that later. Yeah, I just want to make it clear that like what's actually happening on Layer 1 is sequencers who are elected are choosing to commit to a sequence, to a block on Layer 1 by posting a Layer 1 transaction that includes this, like a commitment, right? And it's just like if you want to get technical, it's like a hash or a Merkle root of the transactions in their block. And then they actually propagate the block itself off chain, and that can be interpreted by nodes in the network. So just to make it clear, every app chain has to do this on their own. So if you're the sequencer for 20 app chains, you have to post 20 different transactions to the Layer 1 to kind of commit to those blocks. And you can imagine that's painful, right? And so the simple unlock here is that instead of committing to every sequence of transactions directly and individually, you commit to all of them at once with just one Ethereum Layer 1 transaction. And then if you want to include those other composability features I talked about, which I hope we'll get into more, you can establish, you can kind of break all of these down into their tiniest little Lego pieces. And then if any of them overlap, and you can reduce the amount of like total computation done because you're just doing computation once instead of many, many times. So that individual transaction will likely be expensive, but we believe that the economic value of sequencing so many app chains will be worth it.
Maybe one more question here. You mentioned preconfirmations. How did you manage to do it like in the right way? Because the preconfirmations, there must be some set of validators that tell you, okay, we will include this bunch of transactions in the next block, right? And we now have 12 seconds block, which is quite high for Base Rollups, let's say. And maybe we are going to see 8 seconds, I guess. There is a proposal right now. So what's your approach to this like preconfirmation stuff?
Yeah, good question. So I just want to clarify a few things here about Base Rollups. Every existing Layer 2 does preconfirmations already. What they do is they have a block time that they set to kind of whatever they want, and then a batching time, which is like how frequently they actually post to Ethereum. Anything in between batching times is just preconfirmed, has no economic weight behind it, and can like trivially be reversed by a centralized sequencer. So, if I send my ETH to a friend and in return get his bike, and I do this on a centralized sequencer Layer 2, it's totally possible that this transaction will just be removed when it's batched to Ethereum. And so we actually have to wait for batching to Ethereum and then Ethereum finality to actually get finality on a Layer 2 transaction. And that's useful because it means you don't have to pay as much gas to Ethereum, but has the very strict downside that you can rework in between these kind of batching checkpoints. And so I want to just make clear that like Base Rollups can have sub-second block times. What they have is 12-second batching times, or 8 seconds perhaps. You have the batching time, which is the block time of Ethereum, but the actual block time can be just pre-confirmed, just like it is on every single layer 2 that exists today. And so yeah, block times of Base Rollups can be less than 12 seconds, but the batching time is at least 12 seconds. So I want to make that super clear. And then pre-confirmations come in because all of these block times, all of these blocks need to be quote unquote pre-confirmed before they will be, so they can be useful to users, right? As like a simple example, if I'm trading on Arbitrum, maybe I'm enjoying, approximately that second block times. I'm getting my transactions in fast, and that's a good user experience. But then when I switch to a Base Rollup like Tycho, I might be waiting significantly longer, right? And I think the easiest way to explain how I think pre-confirmations might look is just the same as every layer 2 today, where you pre-confirm entire blocks on a regular interval. Maybe we do like sub-second even. That's totally possible. We could do 200 milliseconds, let's say. And we pre-confirm those blocks and kind of do something like continuous block building on Solana, where the blocks or the shreds that are generated continue to grow and then eventually are released in like one block at the end of the slot. And that is what's committed to on Ethereum. Now, because it's like a permissionless environment, anyone can be a sequencer. We somehow need to hold that sequencer accountable if they decide to do a reorg. Today, that's like sequencers just have a kind of pinky promise and everyone trusts them because of the social dynamics that exist. But on a Base Rollup, this sequencer is like, in many cases, probably not someone that people trust, right? Could just be a random solo sticker. And so you have to be very careful about what you do trust them with. If you want to trust that they will honor their pre-confirmations, you could do that. But an even better alternative for trust is cryptography and crypto economics. And so this is an important part of our business where we kind of facilitate the registration of collateral for offering pre-confirmations, and then allow the proposers that are involved with pre-confirmations to commit to things that actually have a tangible value blocking them. So maybe I say, I will include this block at the end of my slot. Here is 5 ETH of collateral that you can slash if I don't do that. So everyone that's observing the system has like a very transparent way to know that a proposer will actually honor the commitments that they make.
And this will be like some kind of opt-in AVS on Eigenlayer, let's say, or how can I vision in my head this?
Yeah, that's one way to think about it. I think not necessarily like a restaking protocol specific AVS. Like it might be an AVS that exists on Eigenlayer and Symbiotic, or even perhaps which is natively staked to ETH. And so, yeah, I mean, the sharp distinction here is that we want to remain as credibly neutral as possible. And so using any specific restaking layer kind of takes away from that ideal. So yeah, we want to be as general as possible in that regard. But the fundamental truth is the same, is that we want to get collateral from a proposer to a user in the form of a commitment or a pre-confirmation.
Okay, great. Thanks for clarifying this. Andy, if you don't have any other question to this topic, if you have, go ahead.
Maybe I'll just ask one thing. The whole time that you talk, it just feels to me like Cosmos, because Cosmos also had this vision of like upchains and one hub that routes all the messages, which is Cosmos Hub. But it kind of failed. Cosmos Hub, nobody basically uses it for routing, and it's a mess there. The only thing that Cosmos has really, really good is the interoperability. So maybe do you see any risks regarding the same problem? Because basically you're using Ethereum L1 as the hub, and I think it has value in the credible neutrality and the decentralization and so on. But do you see any risks of like routing it, I don't know, through Arbitrum or whatever, and apps will just make base rollups on L2s or whatever? Do you see anything like that as risky for the ecosystem?
Yeah, something people like to say is that Cosmos was right, but they were just early, right? And I agree with that sentiment. Like I think app chains are a failed experiment because they do not offer features that are like requirements to make an app chain practical. I think the biggest one is composability, right? An isolated app chain is terrible for onboarding and user experience. If I want to use Osmosis on Cosmos, then, and I want to use a different wallet, right? I would have to use a bridge from Ethereum, where some of my funds are, maybe from Solana, to Cosmos. And that is the barrier to a lot of user onboarding and customer acquisition, is that bridging, that onboarding step. And like I was saying before, Base Rollups like don't have that step, or if they do, it's like instant. And so I don't think that's nearly as much as a hiccup as it is on Cosmos. So yeah, I mean, I just want to like establish that kind of dynamic here, which is that Cosmos, while it had excellent interoperability between each of these app chains, it never had interoperability with where users actually are. And right now, users are on Ethereum Layer 1, they're on Ethereum Layer 2s, they're on Solana, and Base Rollups that are built on Ethereum Layer 1 can access all of those users directly. The onboarding is so much easier than to a Cosmos app chain. So I think that's probably the biggest difference, is just like the way that the network effects have played out so far. Now you did an excellent question about what about Base Rollups on Layer 2s? So we might call these Layer 3s. That's another thing that we support, actually. It's not something that we push aggressively because there are downsides to using decentralized sequencing on top of a centralized sequencer, which is that it's not actually decentralized. But some apps and some Layer 2s even have shown interest in that kind of design. So it's something we're more than willing to experiment with. We just think that like from a technical perspective, it's not as good as a solution as like a full Layer 2 app chain. Yeah, so I guess the other thing I might mention here is that like there's a distinct possibility that Ethereum Layer 1 fades in usage and activity in the future. But we think that will probably take quite a few years, because as we've seen in the past, like liquidity is very sticky. And there's still a ton of mindshare that's still building on Ethereum. And so having access to this mindshare, to this liquidity, to these protocols, to these tokens is substantially more valuable than interacting with another chain, at least today. And so, yeah, I don't know if that answered your question, but I think there's a lot of differences, which is like, yes, Ethereum Layer 1 is the Cosmos hub, but there's a much better, in my mind, value accrual thesis for Ethereum in this model. And the interop itself is like, it's not just like an archipelago of islands. It's like a massive continent, and then islands off of that can, you can interact with directly. And there's not this like onboarding step into the entire ecosystem as a whole.
Yeah, absolutely makes sense. Thanks.
And actually, let me add one more thing because I forgot. The other reason I think Cosmos app chains failed to adopt a lot of developers is because they're super hard to bootstrap, right? Like if you want to bootstrap a Cosmos app chain as a Layer 1, you need to bootstrap a validator set, and you're probably going to end up doing that with a token. Now, Base Rollups, because of the way that they're designed, they don't need like a bootstrapping step. There's no validator set that you need to bootstrap. And so if you're just interacting with this system in kind of a different way, which is that you're not bootstrapping a validator set, I think that actually makes it a lot easier for a developer to spin up like a lightweight app chain instead of running like a gigantic incentive campaign and giving away 50% of your tokens to validators.
Maybe you can give us some examples of Base Rollups that will launch in the near future. I guess you will know more about this than us.
Yes. So we've had a lot of internal conversations. Unfortunately, none of those are public yet. But yeah, there'll be some names launching in the future that I think you guys will recognize. Rise Chain is another Base Rollup project that's going to be launching their own Base Rollup. I think I'm super excited about them. They're doing like super high scale. Kind of their tagline is like, what if the highest performance Layer 2 was also a Base Rollup? And I think that's it's a really interesting vision, and will kind of break a lot of people's mental model for like the slow Base Rollup, which is just strictly wrong. Yeah, and then Teku Gwyneth is another one that I mentioned at the beginning, and they're working on something somewhat similar to Spire, except they're less focused on app chains and more on like the general purpose side of things, and then sharding that. So different approaches, but super bullish in both those teams, and I hope they're both successful.
Am I correct here that all base rollups will be composable between each other from the day one?
Base rollups that are smart about it, yes. Unfortunately, like the actual interop between base rollups it can happen through layer one, yes. And because all base rollups kind of interact with layer one in similar ways, and it's likely possible to do asset transfer between base rollups if you go through layer one. But obviously that's expensive. And so enabling like messaging between base rollups without ever going through layer one, I think will be important, possible. But yeah, it's tricky to get right, and it's definitely not out of the box. So it's something we're working with other teams on, and something that will totally be supported between app chains that all use Spire.
Okay, so let's give some example here. If I'm on base rollup A and want to do a swap with my token A for token B, which sits on another base rollup, so will I be able to do it like in a composable one block way through Ethereum L1?
It depends on the technology available. Like assuming the existence of real-time proving, then yeah, that's totally possible that the swap would like exist on across the layer twos, be a part of like the same atomic transaction, and each of the kind of applications on each layer two would be able to trust that there's no like foul play that the sequencer is doing between these transactions.
Even if I'm transacting between two base rollups?
Yep.
Okay, didn't know that. The ZK prover thing coming to me more frequently in recent days. Can you tell us something about this? Like, in my mind, I vision it like it's the end game for proving and for scalability of Ethereum, but I know very little about this topic. So if you could maybe pitch it for us.
Yeah. So one of the constraints of existing rollups that kind of makes them not composable is a long proving time, right, or a long fraud proof window. We call this like a withdrawal window in the general case. And the downside of having a long withdrawal window is that you can't like do an action on layer two and then have this immediately reflected on layer one. So maybe I make a withdrawal on layer two. I won't get my funds on layer one for a while. And you can imagine this is the same for like a swap. Like I initiate a swap on layer two, and then it won't actually complete until touching layer one. And in that time, maybe the price has changed, and so I don't want to do my swap anymore. And so we think this is like an important thing to get really correct. And so I want to dive into this a little bit. There's a whole bunch of different types of proving, but all of them have like kind of the goal of proving a layer two block or a batch of layer two blocks, and then being able to verify some execution, some state transition on the layer one, at least in our case, right? Now, the faster that we can do this, the better. If we can do this like in under 12 seconds, maybe even less than 5 seconds, then this is enough to enable composability. Like you can do cross-chain contract calls with this. Before then no, that's not possible. So yeah, that's the way I see it, right? Like the fundamental unlock here, and the reason ZK proofs are actually important, is that you need to unlock the funds in the bridge contract in order to do actions on layer one. So a bridge to a layer two, my ETH is in some bridge somewhere. And then if I, as a layer two, I want to interact with a layer one protocol, maybe I want to deposit into Aave, I could just make a transaction on layer two, have that be proven. So I prove that transaction was correct. And then unlock the funds in the bridge contract, and the bridge just deposits it to Aave on my behalf. And that forms a kind of simple model to support a more, I guess, more complex like back to it. So it's like crushing contract calls are really easy, really nice, but the back end that involves ZK proofs is more complicated. But fortunately, it ends up being a lot more simple than like an intent-based bridge or something where you have to deal with solvers and like capital efficiency that is unfortunately lost in many cases.
Awesome. The way I imagine it, like the future of Ethereum and the fragmentation issue, is that the base rollups are like one step only, but the second step is maybe the share sequencing plus the real-time ZK proving. Am I right here, or is this the way like we should be on?
Yeah, I think the end game for composability will always have something to do with ZK, right? This is because scalability and ZK go hand in hand because of like succinctness property of ZK proofs, but also you need some form of shared sequencing to coordinate proving. So you can prove one app chain and then maybe your users are happy, but to prove multiple different domains, maybe app chains, general purpose layer 2s, you do need some form of ZK, but also shared sequencing to coordinate that. I think base sequencing will be combined with real-time ZK proving to provide what no other team can offer, which is cross-chain contract calls with Ethereum. So maybe you're doing, you could do some external system and have really good interop between other layer 2s. But if you're never interacting with Ethereum itself, I think you're losing a massive opportunity. Because like Ethereum layer 1 is still today one of the top chains by metrics and easily better metrics than every layer 2 today. So being able to tap into Ethereum, I think is going to be actually really important for like the applications and the layer 2s that are looking for composability.
So you're envisioning like our current L2s, like Optimism, Arbitrum, and so on, could go to ZK proving and be composable with L1 through base sequencing? Like really those big L2s that are currently in production, do you think they could transition to base sequencing?
Yes. Yeah, definitely.
Right. Mm-hmm. That's cool. That's cool.
Maybe let's say one example here. It just came to me, but I don't know if it's completely nonsense or if it could work. But if anyone check Etherscan, the top 3 contract is Tether USDT. Would make sense to create a base chain based only on transacting USDT, for example?
Yeah, I mean, so I was talking about this before, like app chains are useful because you can customize everything. So maybe you understand that like stablecoins, if you just have one token on your layer 2 and it's just a stablecoin, you just want payments, which isn't everything that Tether does, and I understand that. But imagine that we're just talking about payments for a second. There's some things that like you actually probably can enable on an app chain that you can't on like Ethereum layer 1 or any layer 2 today, which is like you want to pay gas with USDC natively without like solvers or liquidity providers, then that's super easy on a base app chain, right? You can customize that. Now, I mean, you can also do things that are maybe a little bit more complex, but also more interesting, which is like if you want to do transfers and only transfers on your layer 2, you can change the execution environment, the VM, so that it's not the entire EVM because you don't need that. And what you really need is just that transfer functionality. And so you can make your like state transition function so simple on the layer 2 that it's super easy to prove. And you can have a ZK proof even today in very fast. Your proving time is very low. And so I think that could be super valuable, which is like if you want to exist within the constraints of the technology today, you can customize what you need, right? You're not limited in some way by the collective choices of the general purpose layer 1 or layer 2 that you might have existed on in the past. The other, like, I guess, nice thing about existing as an app chain for like a stablecoin transfer, like payments protocol, is that you're not relying on some like centralized sequencer for uptime. I think like Ethereum has perfect uptime since the merge. There's been a few situations where it's hard to land a transaction in times of high congestion. That kind of finality bug about a year ago, but still excellent liveness, right? Essentially 100% for all intents and purposes. And so what I think this means for financial protocols, payments protocols, that like they need high uptime, right? Like Visa can't go down or else like a bunch of things stop working all over the world. And so I think having a very high consistency, high liveness sequencer that's like a fundamental part of your system would be super valuable for something like a payments app chain.
Based.
You can only get that if you go based.
Matthew, could you tell us what can the community expect from Spire Labs in the next 6 months, 1 year, maybe?
Sure. So we're a software company, so we're building code right now. And we're also looking to connect with applications that are interested in launching their own app chains. So if you're curious, we'd love to ask you some questions, see how we can help. Please reach out. We have the Spire Labs Twitter, Spire_Labs, and then my own personal Twitter. M-Team is loading. So yeah, those would be the best places for people to reach out. More directly, like we want to launch DevNet and testnet in the coming months. Those will be kind of on an app chain by app chain basis, and then eventually we'll start to do testnets that include a whole bunch of app chains, kind of a replica of what would exist on Ethereum. So we can really start to enjoy those network effects. And then hopefully in Q1 2024, we start bringing app chains to mainnet, and then we can really offer an excellent user experience. And then later on down the line, probably in about a year, we start to migrate some of these layer 2s to ZK proving, and allow them to take advantage of cross-chain contract calls with Ethereum and really unlock that like entirely new paradigm of composability.
Great. Thank you, Matthew. It's been a pleasure to having you on the show. Thanks for your time, and maybe see you next time.
Yeah, I love you. Thank you so much, guys.
Thanks.
Bye.